So thank you, everyone, for coming here tonight. I think it's just kind of want to do a little PSA. It's really, I think every BAYBRAZIL event, it's really kind of remarkable. Tonight, we're going to have a chance to kind of hear from some of the most brilliant minds in the iconic companies of the Silicon Valley, right? So we have, brilliant engineers from Google and Amazon and Facebook. So I think it's really, really a privilege for me to kind of moderate a panel with you guys. And of course, if you want more of this, which you should, become a member of BAYBRAZIL, right? It's not expensive, and it's really, a bargain. And I really encourage you to do that. So end of PSA, but do it. So I want to just kind of get started and then kind of bring our panelists. And despite I work with with a team of machine learning engineers. I actually have one of them sitting here today, and it's like you get used to the things that are possible, right? But like every day you look and there's a new application for it that is just just blows your mind, right? And I want to talk a little bit about three kind of little interesting applications, and then bring the panel in, and then we're going to kind of pelter them with questions. So let's do that. Hopefully, yep. All right, okay. So the first one that I want to, let's see if this thing works. Oh, yep, here we go. So the first one that I want to show today, and you're going to have, hopefully we can see clearly enough, because this is kind of, it's a weird video, but I'll explain. So the first one I entitled it, like, the machines are coming, right? So I'll play the video, and then I'll talk about it. Let's see here. All right, okay. Let's zoom in on the action there. So you can see the person's putting something there, and that is a cucumber, right? And the cucumbers are kind of going along, and then they're going to the bin, right? So what's happening here is kind of very, very, very interesting. So this guy is like a Japanese engineer, and he retires, and he goes back to his family farm, right, which is a cucumber farm. And then he realizes that in the cucumber farm, his mom spends all her days basically sorting the cucumbers, because as it turns out, straight cucumber has a lot more value than a crooked cucumber. So he figures out that maybe I can do this better, right? And with like maybe $1,000 worth of hardware, and actually a product from Google, like Google TensorFlow, he basically trains an algorithm, right, to take a picture of the cucumber and then guide the robot to put it in the right bin, and then sort that. So essentially, he's replacing his mom, right? So it's yes. However, they're not quite there yet. So it's like right now, I think at least when they made the video, it was like 70% accurate compared to his mom. So his mom still has an edge, but the machines are getting there. So let's see the next one. Yeah, OK. So this is an interesting too. So I titled this one, They're Learning to Walk, right? And I think one of the things about machine learning is, until now, when you want to extract value from a computer, you essentially have to program it, right? So you have to dictate, how it's going to work, and essentially create a set of rules, right, or many, many rules on the things that are going to that the computer will do. But as we know, it's really hard to create a set of rules for things that we do very easily day to day, like riding a bike or even walking, right? But we're getting there, and the video is kind of a little bit pixelated here, but you see like a neural network, which is one type of machine learning algorithm, being trained over oops, I kind of spoiled my next one. Okay, so let's try that again. Yeah, so this is like the first generation, right? Let's see how it does. So they're gonna try to make the little kind of like software robot do what it's supposed to do, which right now nobody wants to do anything here. Let's try again. And maybe this video is not gonna load. Oh, let me just go back one here and see if it works. OK, I think now it goes. Yes. So first time it tries, it just falls flat, right? And it's kind of like trying to get up. And this is like, you're not programming any instructions. You just kind of put it like, OK, here's a reward for you, and this is some basic kind of constraints, right? Then now it's kind of going forward. It falls face flat on the floor. And then as it evolves in the generations, you're going to see that it kind of starts to get what it needs to do, right? So you're training this multiple times in a relatively powerful computer, and then eventually, as it gets forward, it kind of gets the hang of it, and then it learns to walk without ever being instructed what it's supposed to do, right? So I think that's a very, very powerful thing. If you think about it, if we can do this on the screen, we can actually make robots walk as well, right? Which is a big, big problem, and but to this date is a kind of still not super solved problem. So, and then finally, just want to show the last one. It's a bit of a challenge here. And actually, thanks to Kartik, they sent this, and I failed the challenge, by the way. Which faces here were generated by a computer that learned what faces look like and created a new one, and which one actually, or no, actually, let me ask you this way. Find the real face here. Anyone has an idea which one is? Find a real face here. Pick one. Anyone has?
The woman, bottom, that one, yeah.
This woman? OK. Anyone else wants to pick one? This one here? This one here? OK.
None of them.
All right. You all failed. All these faces were generated by a computer. And they're actually different. They're different. I didn't say there was one of them that was, but the interesting thing is you can see some of them are pretty, pretty blotched and not well done. But as he learns, right, and the way you do these kinds of things, you can set like one machine learning algorithm trying to generate a face, and the other one trying to guess which face was generated by a computer, right? And they play each other multiple generations. And eventually, they both get better and better and better, right? So you can see where this is going. So it's going to be hard for us to tell, and in some ways, it's kind of like we'll have to figure out how to navigate this world, what was synthetic, what was generated, and what's real. Anyways, this is what I had, and I want to invite our panel here. So I'll start with Anima, is a principal scientist at Amazon.
Yeah, Amazon Web Services.
Great. And then we have Rodrigo Smith, with engineering leader at companies like you've been at Facebook and Instagram, yes. And then Samuel Soto, who you're staff engineer at Google.
Indeed, yeah.
Yes. Mm-hmm. OK. So let's sit down, and then I have some questions to just kind of get started, and then turn to the audience. Let me get my little kind of a cheat sheet here. Yeah. So Anima, I'm going to start with you, which is when you look at the problems in machine learning, right, that are being solved today, which ones do you think are really interesting, right?
I mean, to me, this is the golden era of machine learning, right? So I've been a professor at UC Irvine for the last 6 years, thinking about problems like unsupervised learning. So if you see a lot of advances that have happened today that has come about not just because of the algorithms, but also because of annotated data and lots of compute power, right? So, but for more complicated tasks, we don't simply have such huge amounts of annotated data. So think about, the current set of tasks looks like, OK, I have an image. I have a label of what the image is about, right? But if you think of a complex real-world scene or maybe even a video, how do you describe everything that's there in the video, right? So it's very expensive to have annotations and labels generated for millions of such samples. And so then the question is, how do we do unsupervised learning efficiently? So can we learn representations of the world without having access to labels? Right? So it's been argued that humans tend to do a lot of unsupervised learning, especially as children. You're gaining knowledge of the world around you without necessarily always having supervision or a goal. And so the question is how we can enable unsupervised learning. And the video that you saw of GAN, or the generative adversarial networks, is one instance of generating samples in an unsupervised way, right? So the question of how to do it for complex multimodal data, and how to bring in maybe some help from humans to generate more realistic images and other kinds of natural data is an interesting topic. And another one that I find very interesting is in the realm of reinforcement learning, which he also covered. That was the robot, just without any information, over lots of trials, being able to get up and walk. And this is great in simulations, right? Because we can keep doing this over billions of runs. But then in the real world, you can't wait that long for the robot to start walking.
And it would trash the room as well, right?
Exactly. And then the question is, how do we bring in the knowledge from unsupervised learning, from transfer learning, from known existing tasks, and help reinforcement learning get better with far less number of trials than that robot had to do. So that's, I think, another very interesting area that I see.
Nima, I think something you said, I think is so interesting, right? This idea that you have to learn something, and then eventually you figure out what the label for that something is, right? Or you get and it's kind of I have like small children. It's kind of interesting to see that even when they learn, they seem to learn the concept of the object, and then eventually they seek towards you, like what is the label for it, right? And then they do that. Samuel, do you want to pick up from there?
Yeah, no, those are all exciting things, and yeah, traditionally where AI research is going to. I'm generally excited about the areas in which this can, some of the areas in which this can have a big impact on, and some of the ones that I'm more excited about are things like medical research, for example. There were some early results that a lot of these algorithms are starting to be better than humans, right? Like for cancer detection, eye cancer detection, and so just across the board, it seems like a lot of these new algorithms are coming up are performing better than handwritten algorithms or even humans. I'm following a discussion in the computer vision research that a lot of the algorithms were crafted manually. Yeah. People were writing these manually. They were like manually writing like power density, all the Bayesian network work, and they developed all these mathematical functions in computer vision, but the neural networks are performing better, yeah. Right? But they can't explain that. They don't know why, but they're performing better. And so, just from a research perspective, a lot of the research is changing a lot too in other fields because of AI. The other concrete example is machine translation too. Like machine translation has been traditionally solved, prior to a lot of the AI world, manually looking at grammars and understanding language and, translating as humans would translate things, understanding the structure of the text. But, more and more better results are coming up just by the nature of the sheer volume of data that we have. From a research perspective too, I'm excited to see a lot of the kind of like more the engineering platform research too, like with TensorFlow and with much of the neural network wasn't successful early on because the computers weren't as powerful to perform these many layers of reinforcement learning, right? And so the computing platforms that exist today with cloud and with MapReduces and distributed systems, they enable like a new level of computation, right? A new level of that wasn't possible before. And so that's another area that enables AI that I think is interesting.
It's fascinating. Rodrigo, what's your take?
My take on this. Okay, I'll try to take a different. I agree with everything everybody said. I'm interested in seeing there are two things. Like I'll break it in like two parts. Like the first one is there's this whole set of things that we do on a daily basis that they require a significant amount of training from our part. Let's take a simple one. Let's take driving as an example, right? Like driving is like a fairly complex task that we perform. It's you don't realize how hard it is until you have to teach someone how to drive. Like you drive on a daily basis and you're like, okay, this is easy, I can do that. But if you have to teach somebody, you realize how complicated it is. It's not that simple. Like it's simple for you because you've been doing that for years. But let's say for your teenager, son or daughter, they've never tried that. It's a simple synchronization of the feet to go from the accelerator to the brakes. It becomes very complicated because at the same time that they are doing that, they are looking around. There's so many signals coming in. But so it requires a fair amount of training. You can see how much time it takes. It takes months, potentially years, for somebody to learn how to drive. But then once you learn those things, it becomes extremely boring. like very often I find myself, because I wander on my thoughts like every day. And very often I find myself like driving on the freeway. I don't even know that I'm driving. I'm thinking about like everything else that is happening in the world. And all of a sudden I'm like, wait, like I got there already? Like it's been like 20 miles? Like how did I get here? I don't even realize, because it becomes automatic. And it becomes like kind of like very simple, like a very simple task for us to do. And it becomes like a burden in many ways. Like there are many times like, I wish there was something driving for me, because like this is like, it's just like it's not a very like complex task anymore, even though it's like very complicated to learn. So I think like there's like with the advancements in like, I remember when I started when I was in college, and I remember professors talking about like neural networks and it's like training like your neuron and stuff. It was like, but we didn't have the capacity that we have today. We didn't have the technology, both in the capacity in computational power and also like efficient algorithms to handle those things. Now we have those. Like now we have both. Like we have the technology, and now we got to a place where we can actually implement those like fairly complex like cognitive skills that like are like human, like have human capacity in many ways. Like for example, like I was. Let's continue on the example of like driving cars. Self-driving cars are getting to, and they're not perfect. I still think like there's going to be years until you can actually like hop into a car and ask it to drive you to, I don't know, like downtown Palo Alto, and then you do nothing with the car. Like I think there's still like a lot of randomness that happens in traffic that the car, like it's going to be hard to train a car for. But it's still like you got to, like you see those demos, and it's like, oh my God, those are like basic like driving skills that might take a human like months to learn. You can now like do, you can have systems, you can have robots that do that for you, that have the capacity to learn those things and perform those activities. So you can extrapolate. If the technology exists and you can apply that to let's say like self-driving cars or like image recognition, like you can extrapolate that to like a number of other things that are like extremely boring once you become an expert in those things, and now machines will take over. And I find that like particularly fascinating because like think about, I was talking to a friend earlier today actually, like think about financial investment or like tax returns or it's like all those things, they're so complicated at the same time they're so boring. I was like, once you do your tax, like I remember the first time like when I came to the US like almost, I don't know, like 9 years ago, first time I did my tax returns, I was actually like having fun with that, like because you were learning through the process. Like, yeah, it's fairly complicated, but I'm a geeky guy, so like I would like to understand how it works. Like it's a set of rules, and you're there like learning the rules on the process. The first time is like, yeah, great, like I learned something. The second time is like, oh my God, this is hell. Like I'm going to spend 2 days, like I could be doing anything else, so I think like I can foresee, and like it's already happening. Like I've been talking to a bunch of friends who are in the like thinking of building a new business or talking to other businesses in the space of AI, and you see like a multitude of companies coming up exactly with those ideas. Like how can I disrupt like tax filing, or how can I disrupt financial investments, or how can I disrupt telemarketing? Like telemarketing, it's a like extremely boring task to perform. I'm not saying like from the consumer perspective it's even worse, but from the worker like perspective, you're there sitting on a desk like the whole day, calling people and following a script, and that's pretty much what you do. It's like, but it's still like it's such a complicated like it demands such a complicated cognitive skill set and like training that you can't really you couldn't automate until now. But now we're starting to see technologies on human voice recognition and voice reproduction that are very close to human. Like I'm guessing, like if you all have smartphones, you have that technology on your pocket right now, and it feels silly, the technology that we have in our pockets today, because it only understands simple questions. Like you can ask Siri, like, hey Siri, what day is today, or like what is the weather like? But we are getting to a point where we can start to introduce context in those conversations, and like we can start building systems that can understand the whole context of like a longer conversation, not a simple like question answer. And then you can imagine, like I'm already starting to see some prototypes here and there of bots or like systems that can they can record a conversation, or they can monitor a conversation and then evaluate that conversation and provide some feedback. It's like this conversation is going in the wrong direction because people are just starting to become more nervous, or they are becoming like more anxious or angry, and then can provide you feedback in real time on how you are performing. So we're just like a couple of hops away from actually that system taking over. And starting like having that conversation with you or anybody else, and like taking over those responsibilities. I find like that whole space like fascinating to me. And what I think it's the most interesting part of it all, which I've been thinking a lot the last few days, is like what does that mean for for us like humans in a way, as we have to adapt to that world. Like think about like the Industrial Revolution, right? Like before.
Can you hold on to that
Sure.
thought? Because we're going to get there.
Okay.
So I want.
If I may add just a couple of examples, because you gave really good examples. Those are really, really good. But you used a word to describe them, which are boring tasks. But the most interesting aspect of this, to me, or what's happening now, is that machines are starting to perform better in tasks that we would traditionally correlate with creativity or human intelligence. Concrete examples are music composition. Like, machine learning is starting to compose. These are public results, so you can see them in the research literature. But machines are starting to compose music, right? Like, who would know, right? You would traditionally think that music composition is something that requires like, development of a taste, development of a genre, development of skills that you would associate with human intelligence.
It depends on the music.
Indeed, yeah, it depends on the music. The other concrete example that I think it kind of like starts getting into like less like text filing, but more into elegance and thinking is the results that we have had in AlphaGo, right? In Go playing, Go has been traditionally a game where it takes a lot of human intuition, and it takes a lot of things that you can't solve by brute force, right? Chess we solve with brute force. We solve by minimax and alpha beta search, algorithms that were they were crafted for solving chess. Whereas AlphaGo, it was an algorithm designed to solve arbitrary things. Yeah. And so it gets really interesting, if I may say, or perhaps scary, when computers may be able to pass human ability to produce even things that we traditionally consider as human-like.
And before we go to the audience, because I imagine you guys have lots of questions, I want to do like a quick round on one question. Just try to answer at the same time. Which country is leading machine learning?
Currently the US, I think.
I mean, definitely the US.
Okay.
In terms of like researchers and in terms of the companies, what's been coming out, but that equation is changing very fast.
Yeah. Well, what do you think?
US sounds right to me, not just from academia, but also from the industry. But there are prominent researchers outside of the US, both in London. There's a very famous Brazilian too.
Okay. Interesting, no one mentioned China, right?
Yeah.
Oh, Andrew N was at Baidu, but I think he left.
Yeah, that's right.
But yeah. And what's funny though is that a lot of the interesting research is starting to be done in the industry rather than academia. Maybe because of the computing power that was needed, maybe the industry was able to provide. But Amazon obviously.
And I think one aspect of that also we want to think about is democratizing the machine learning and having access to compute resources for everybody. Right, so at Amazon, we have a number of programs to have cloud credits for research, for education. And the question is, how do we take it to the, I think there's an echo, or is it just me?
It's pretty good.
Okay.
It's pretty good. Yeah.
So how to globalize it and have all communities have access to the latest machine learning technology as well as the compute resources. And to me, the one thing that differentiates the current machine learning revolution from the previous revolutions, say, could be in the optimization community or in other areas of how research has gone into industry, right? There's been a lot of closed source work, but we've been doing open source. There's been TensorFlow from Google. Now Amazon is working on MXNet. It's an Apache open source platform. So a number of companies have been doing open source work, and we are all sharing this knowledge. And to me, that's a unique and a very positive force in this revolution.
Yeah, I couldn't agree more. And there's some parallels to be done with the Industrial Revolution and agriculture too, I think, where the people that dominated the technology were able to concentrate all the power in the financial gains, whereas maybe this will be one where more people will have access to the tools that they need to succeed.
I have another one, kind of lightning round for you guys. If we look at jobs, right, like overall economy jobs worldwide, maybe 20 years from now, more jobs, less jobs, or just different jobs?
Different jobs?
Different, yeah.
Different jobs, different jobs.
Yeah.
Okay. All right, that doesn't sound bad. Okay. All right, so I want to open up to, do you want to make
no, I think there's one problem there, which is you're going to feel like, you're saying, well, it's not bad, but it's like the different jobs is like a pretty hard thing, because remember what I just said, right? Like you are trained to do one thing, and especially the way education works today. Like you spend years in school learning a certain capacity, and let's say college, you have a specific domain that you gain expertise on, and that's supposed to be your job for life. So in what happens, those kind of, as I said, even fairly complicated cognitive tasks in the future, they'll be able to be much more easily automated. So what that means is people that will rely on that old education style and that more static kind of training, they're going to be stuck, and there's not much that you can do. So it's different jobs, but you're going to suffer the consequences of the two things. There's going to be a lot of people without jobs, and at the same time there's going to be plenty of jobs that nobody can do because they're going to be more advanced. And potentially you might need, I know this is a little grim, but potentially you might need an extra generation to come in to actually be educated in a different way to compensate for that. And maybe by then technology will evolve again. It's now it's another.
I think what you're saying is so true. I mean, I look at, I think that the educational system still has I guess the vestiges of the Industrial Revolution, where being good at repeating things the same way with the same quality is rewarded, right? And being able to do those things. If you're in a factory line, if you do the same thing, like a robot, right? You're probably a good factory worker, right? But that's changing. Even factories, if you go see the factories here in Silicon Valley, right? The few ones that exist, the people that they hire are different people, right? And they have different skills. So I think that's going to definitely have to change. Yeah.
And being adaptive would be the most important of all the skills, right? So always continuously thinking about how the world is going to change and being prepared for that. But I think that's a skill set, and I'm especially worried about the population, that's more underprivileged, right? It's, so it's easy for us to say, let's, all they need is some retraining and it'll be fine. But the worry is, for people who, are worried about their day-to-day meals or their needs not met, how do we ensure that they can keep moving in the new economy and make this transition? So there's been the idea of the basic universal income.
Yeah, that's right.
I think that, before the AI revolution really has these changes that can be catastrophic, I think more thought needs to go into it.
But aren't you afraid for our own jobs in a way? I kind of I have that fear too, because I think I'm super scared for the underprivileged, but at the same time it's not only being adaptive. It's almost like being meta adaptive, because machines are learning to be creative. It's I think the only thing after the It's like, let's use that reference to the Industrial Revolution again. It's like, so those very simple like tasks like hammering something, robots can do. Sure, like now the phase we are going through now is like you need to be adaptive. So like that is us. I think like 10 years from now, what is going to happen is like machines will be adaptive. So now what? Like now, what do you do?
We need to design better machines that can be even more adaptive, right? So that would be the kind of jobs.
I think that this is, who has seen the movie Hidden Figures here?
Yeah, that's a good
So
example.
there's a great scene in the movie where, there's like this group of women mathematicians, right? And they basically, they're very good at calculating, right? And they needed that for the space program. And then at some point, one of the women sees like one of the first, mainframe computers being wheeled in, right? And then they're like, this is gonna make all the calculations super fast. And then she basically rallies a group of the women to learn how to program the computer, right? So she had a pretty, white collar, kind of like highly regarded job. It wasn't like like a low end job, but she saw that even that job was at risk at that point in time. And that's true today. I mean, I think, the panelists mentioned several things like medical imaging, lab technicians, right? I mean, this is a highly paid job. These jobs may see a big revolution happening, right? So we're going to have to adapt. I want to maybe give a chance to I have lots more questions, and I can see you guys have tons of things to say. Hidden Figures. Yes. Great movie. Yeah. I think there's a question there in the back.
Okay, I've got a question. So for Anima, right?
Yeah.
What is the role of play in unsupervised learning? Or is unsupervised learning another way of saying play?
That's interesting. So I guess by play, you mean like explore different strategies and...
So having an outcome?
Right. And, so that's kind of closer to what, the area of reinforcement learning, right? So play essentially also means the environment is adaptive and changing with it. So that goes into the realm of reinforcement learning. So the traditional unsupervised learning has been in a passive environment where the environment is static and you're trying to learn about it. So in the reinforcement learning realm, play is typically, you do kind of simulated plays to come up with strategies that you think will be based on how the environment is going to react in the next set of steps. And so there is the question of, do you want to do self-play? That means you have a current idea of what the environment is, so you play against that and improve your strategies. But this by itself is limiting because you don't know everything about the environment, right? You haven't had the complete picture of environment. And so typically you also want to explore, meaning think about new possibilities that you haven't yet covered in your current picture of the world. And so there's been a lot of interesting questions of how do we combine these strategies from experts, right? Because you may also get outside information of experts showing you how to play. And you may have your own play strategies based on the model that you've come up with so far in the algorithm. And there's also some interesting frameworks using crowdsourcing and coming up with having humans play them and look at diversity of strategies and how to combine all that together to come up with a very efficient strategy for the game.
Typically, we think that machine learning is going to do something for us. Is there a chance that machines can decide that they don't need us?
No, the singular.
Well, yeah, that's
You're building the Google brain, so go talk about that then.
Well, no, so I get the argument. But I think there are multiple parts to this discussion. There's the 100 years, 1,000 years, but maybe in a more concrete terms, in 4 or 5 years, right? There's a debate in the industry specifically about the past elections when it comes to fake news, because to a large extent, what you search on Google, and with the stuff that you consume on Facebook are largely given to you by algorithms, right? And so it's not so much that the machines are trying to take over stuff, right, or create wars and whatnot, but to a large extent, to a large extent, when you're in a social network, there's a debate between whether the algorithms should provide to you what you want to hear, or whether they should provide you an ability to learn about something new. So a concrete example is, if you search for Hillary Clinton on Google search, right, is the right result to give you things that are aligned with your opinion, right? That give you validation about your opinion. You pick your favorite subject, right? Is coffee good for health or not? Or is sleep training good for my kids or not? Pick any topic, right? And ask yourself whether, when you look for that information, whether you're looking for validation of your opinion, or whether you're looking for an opportunity to learn about different aspects, right? Or ask yourself, if you are browsing your favorite social network, right? Whether you would like to see whether you'd like to be in a comfortable bubble where you're, engaging with people, like-minded people, right? Or whether you would want to sometime, every now and then, to have a post inserted into your screen that maybe opens your mind. And so, I buy the argument of, in 100 years will machines dominate us, right? But to a large extent, they already are influencing, algorithms already are influencing our short-term society, right? And in the long term, jobs is obviously a good, interesting way that they are changing society too, and that may lead to things that, the Industrial Revolution certainly led to a lot of friction in society, right? And so I don't think, when people ask me that question, I don't think in terms of, will machine dominate us? I think more along the lines of, will our opinions be based on stuff that we don't understand? For example, if one of the discussions in the research area is that with deep learning, you lose the ability to understand why they got to that result. They can detect cancer, but you don't know why. They can drive a car, but you don't know why. They can compose music, and you may appreciate that music better, but nobody can explain why, right? And so if they can compose music that's better than anybody else, right, does that mean that they will, some things may go undetected, or some things may lead you to places where a human wouldn't normally do, not because they are evil in themselves, but because they are optimizing for what humans want you to do, which might be like stay ourselves in isolation with one another, just with people that like your opinions, right, or may not.
And I think one of the additional dangers, right, of such machine learning algorithms that have only one objective, or that are trained, that are designed only with one viewpoint, right? You don't think of all the implications, is they could amplify all the biases that we have in our current society, the racial, gender, and the different biases. I think there was an interesting paper on how, if you look at word embeddings are these representations learned over lots of Google News corpus, and and if you now they look at interesting relationship, like you can say, given this word, what are the words that it's closely related to, right? So you can come up with this in an automated fashion based on learning from this large corpus of data. But what happened was it also picked up the biases that if it's a doctor, that's closer to being a man than a nurse is closer to being a woman, right? So there is and if you use the system to now recommend doctors in the area, and somehow this comes into play, right? And that's the other hard part as well. We don't know how it's going to come into play because there are all the complex correlations in the system. And that is the other danger, that one view is the AI would make the world more fair and remove the biases, but the other danger is it may amplify the biases and drive us towards solutions that are even more dangerous and scary.
Yeah, I think this is first I feel like the dichotomy between human and machine is actually it's been broken for a long time. In reality, we're no longer the animal that we originated from, right? Reality is that we have been inventing things, and even before this, like when we invented the printing press, and now we had a way to store information outside our minds, right? And animals don't do that. And then now everyone is really superhuman, right? The reality, because you carry something like this, you'll have access to the world's knowledge. You can summon a vehicle from some company. You can,
Nice one.
you can do so many things, right? You're here watching this presentation, but you're somewhere else, kind of just briefly chatting with a friend. So all of these things are superhuman things that we have now. So I think it's inevitable, it's already happening, that we are merging with the things that we're creating, right? Now, the question is this merger going to happen fast enough? How is it going to happen, right? And then will we be one thing before, potentially we actually have a breakthrough and the machines take off, right? And I think there's a lot of, I guess, esoteric, somewhat discussion in the industry about these things. But I think it's an important thing. I also think the point on bias is huge, right? Because even if we were to train these machines to do things right now, we would, like Microsoft did something that was pretty interesting, right? So they created this, machine learning chatbot, and they put it online, and they let, the internet train it, right? And in a matter of like a day, it became, it started really nice, and it became sexist, racist, and they had to shut it down because, that's the internet. So, question there in the back?
What are your views in terms of AI on public policy? There's a debate about the federal government, the local governments using AI to make better decisions in their communities. And I've watched a few of these debates, I've read up on it, and there seems to be a lot of conflicting opinions on both sides in terms of the use of it. And then going back to your point of bias, for example, prison sentences, how to correctly, get the correlation between a crime and what the right sentence is, as opposed to, you see a lot of people today who steal something and spend 15 years in jail for maybe reasons of bias or whatnot, or education, where you could use AI and AI would correct it. What are your views on AI in terms of the public policy realm?
I mean, to me, the aspect of having, not even AI, right, at the very first level, having all the data access and keeping this in the open and having transparency is the first step. And we've seen that already helping. Like in the social media, there is outrage when the sentence, there was this rapist from Stanford who got off with a life sentence, and then that led to a huge cry and then questioning of how sentences are, the judges have so much power on how sentencing is done. And so to me, that aspect of, that we are talking a lot more, right? And especially in this current political climate, we are talking more, we are discussing more, we are also having a more global view of, all the communities coming together and talking about it. But there is also the bubble phenomenon that's one of the dangers. So to me, like interaction and discussion about public policy in social media is a very positive part. And the other aspect of whether AI itself will be used to make decisions or help make decisions about public policy, right? I mean, to me, it's still not at the stage where it can make automated decisions, and that's dangerous. Because also the question of what is even the right objective function? Right? There isn't a single objective, it's a multi-objective system. And if you think about fairness, again, to what level of fairness do we ensure for all the stakeholders is an interesting one. I mean, to me, I would love to see it mathematically formulated at least and come up with a solution. And then we can debate if that's the right solution. And now we have the tools to do that at scale. And to me, that's the interesting part.
I would agree to most of what you said. They have a saying, a joke in AI, that they say that when a problem is solved in AI, it's not AI anymore. It becomes an algorithm. And so consider AI anymore, like social networking or like elections, for example, voting machines, right? Things along those lines. They are not AI per se. They were derivated from early AI research, but there's a lot of the government should catch up. In those terms, like voting specifically. Maybe healthcare has a little bit of a space for more data mining, perhaps. But one of the things that came up in earlier discussions was, it's not in public policies, but it's in the military. Like once you start having a self-driving car or a drone, right, then connecting something that goes through, that's useful for the military, it's an easy derivation, right? And it seems, if I understand correctly, the status quo, at least that I think people have converged to, is that it's very dangerous to go that route of, applying AI for military usage, because once you do, then it becomes something that non-state people can use it too. Not governments, but regular civilians, and so that becomes dangerous to apply AI in that regard. So other than the military, maybe healthcare, but like I said, there's a lot of basic computer science stuff that isn't AI per se that the government could use.
Just to add one more point in that, there's also an article in New York Times May 1st. It's titled "Sent to Prison by a Software Program's Secret Algorithm." So actually it happened in Wisconsin court where they used a software to predict how probable this particular defendant will commit another crime. And they actually used that software to kind of increase the sentence. And when the defendant asked for I need to see the software because the algorithm is secret, right? The defendant asked for I need to see the algorithm, and the company who made the software kind of claimed that as a trade secret, and the judge kind of went away with that. So the defendant couldn't actually see the algorithm but got a sentence from it. So how do we know that that algorithm doesn't have a bias?
And the European Union, right?
Wow, that's interesting.
And the European Union now has a regulation, I think by 2018, you need to have, it's called right to explanation. So any algorithmic decision that's made should come with an explanation.
What's the deadline again?
I thought sometime in 2018 I could be.
But then how does that
Yeah. So again, what does an explanation mean? That's itself, right? Because you can obviously generate the code, right? Okay, these are all the layers in the neural network, and that's why it made the decision. But that's meaningless
it's not only the code or the framework that you're using. It's the whole data that I don't know, let's say you have a sparse model with thousands, millions.
So the training data that has gone into it, right, is another important
the algorithm.
thing. Right.
And then there's no way that you can. First, it's too much data, and it's all you can't spend your lifetime literally just going byte by byte for that data. It's still you don't understand the reason because it's beyond human understanding in that sense.
But at the very least, maybe having some closely the features that were most dominant that led to this decision, right? I think giving a little more insight into how the algorithm processed is the first step. But this is very much an area of research of how to interpret these models.
We're talking about deep learning neural networks. Those are hard to explain. Let's put that way. But more traditional logical systems are explainable, traditional knowledge representation, first order logic. A lot of that can be applied to law, and that leads to something that you can comprehend as a human. And so perhaps not the machine learning aspects of artificial intelligence, but the more basic traditional knowledge representation systems, expert systems, they may lead to things that are comprehensible.
My name is Fernando Rodriguez. I'm from a company called Keep Coding. I can relate to you because we train not exactly humans, nerds, which is a kind of an in-between species. It's hard enough, so I know what you guys are dealing with. But I'm also old enough to remember the AI winter of the end of the 80s and the 90s. So what went so wrong at that time? Why did it tank? And why do you think it won't at this time, if you think it won't?
Right. So what happened in the 80s was there was a lot of excitement because the computer technology was just starting to get better. And so going from this tiny perceptron or a few neuron network, people were starting to build maybe 3 layers, 4 layers, so getting to the next set of more complex networks, right? So there was a lot of excitement that you could now process a lot more data, build bigger models. But it just wasn't there. It's all it needed. These models can only work when you have a huge amount of data, right? So the ImageNet data set has millions of images. So only then it started getting competitive and better than the hand-engineered features. Because if you don't have enough data, you cannot learn all these representation from data itself. And that's where this hand-engineered rules of, maybe I can kind of look at this, shift these shapes, or look at Fourier transform, and all these fixed rules help because there isn't enough data, you need to be creative and coming up with rules that may help you detect the image better. Or say this, this text document is having like a particular topic, right? So you need to come up with creative rules to help do this because there isn't enough data. And only when the amount of data grows beyond a point, then you can look at all the patterns directly from data and come up with what are interesting features. And that's what the deep neural network is doing. It's starting from very basic shapes, think like lines in different angles, maybe curves, but it's composing them into shapes that look like real objects, right? It's building in the inductive bias that happens in the real world. And so, but to do this, it needs lots of data. So to me, that was one aspect, that data wasn't enough. The other was the compute infrastructure. So in some of the talks I give, the slides I show involves like 256 GPUs or so, like a few hundred GPUs. And when I was computing, I was calculating how much compute power that is. That's more than a petaflop compute power. And if you look at the world's fastest supercomputer, that's about 93 petaflops. And in the earlier generation, when you look at Hidden Figures or just the generation beyond that, these were only in the big national labs, and you had to wait years to even get any time, even for an hour on these machines. You had to plan your experiments way ahead, right? And now I have some of the interns and students working on such large amounts of compute infrastructure, and that's another important one. Like these models only work beyond a certain scale. So when there's small data, small models, it's pretty much useless, right? So only at this high dimensional setting do we see the power of these
Now you
networks.
can just ring your credit card on AWS or Google, and boom, you got,
And everybody else can do that too. I think that's the other beauty of it, that we are making it seamless and easy for people to launch machine learning jobs on the cloud infrastructure, at the same time bringing down costs by asking how we can have efficient scaling, think about energy costs as well. So I think there's lots of interesting questions there.
I'm with her, like everything that, but if I may summarize, one, I do think this is a different game. This is different than what happened in the 80s, specifically because the results are better than human-crafted algorithms and human abilities, right? And so in the 80s, the results were just not there. If you crafted an algorithm yourself, it would be better than neural networks, right? Not today in many applications. I'm not saying that there's a little bit of hype, so we'll have to go through this hype and see where they break, right? But it's a different game, and like she said, it happened for 3 reasons. Moore's law, we have more transistors per centimeter as we did before, exponentially, right? The internet happened, and so everybody has their digital data in digital form, right? Data exists, and neuroscience evolved too. Right? We learn about reinforcement channels. We learn a lot of the things that neural networks are based on that we didn't have that in the 80s. And so I do feel like this is a different game.
What's your take?
I don't think I think I agree with you. I think like it's a different game, like in the evolution. But like the basic theory was there. That's the thing. Like that didn't really change, right? Like the same.
The 60s, right?
Yeah.
Exactly. Like
right?
it goes back like a long time.
And that's why data and models,
Yeah,
compute power is the...
I think the main things were those 2 things. Like you just didn't have the access to the data, which now is like ubiquitous, like with the internet and everything. Like I remember like computers when I started into computers, like in the 90s, my first PC I think has had like 2 or so like gigabytes of disk, and it's like that is like and a few K of RAM. It's like you don't have even the capacity to like hold the data that you need to train like a simple like neural network. So like the only things, and I remember like my AI classes and stuff. Like the only like things we could do with AI to learn AI back then were like simple tricks here and there, like with like very simple systems. Like we were building those things like, yeah, sure, like this is worth nothing, yeah, because you just didn't have that capacity, right? The computers were not connected. You couldn't use distributed computing the way you can do today. Like have fast networks, like fast throughput, fast connections, like high throughput. And I think like that the technology like advancements were like key here, like not so much like the theory. I think Jan LeCun from Facebook was saying the other day that a lot of people gave up on that because they couldn't progress in their research, and they're like, no, I know he thought like, well, eventually technology would catch up, so he continued in that field. It paid off. Like he is a very celebrated researcher now.
But at the same time, there was research in other areas such as probabilistic models. And now what we are seeing today is a convergence of those areas, right? So neural networks are more deterministic. And at the same time, we want uncertainty because we also want to model like the randomness in the world. And so there's been a lot of new research that brings the two closer together. So I feel like research has also been evolving to ask how we can bring in new algorithms, faster optimization technique. So there's a lot of open problems, and in my university research, I've been thinking a lot in terms of how to have faster optimization algorithms, think about multidimensional data analysis. So if you like have data that's like, say, a set of entries, that's a vector, right? That's just like one dimension. You can have a matrix. You can say like, like what are the users, what products they liked. That's a matrix. But if you now keep going to higher dimensions, it could be not just users, products, but like what type of user, like what age and so on. So there's all these dimensions that the data lives in, and so asking how tensors and the algebra coming from tensors helps us process this better. So to me, it's the golden age to do research that combines math with computer technology and thinking of massive amounts of data. And that's a very exciting part.
Question to the lady over there.
Yeah, so I'm hiring my first AI guru. I'm excited.
Congratulations.
I'm curious to hear you guys' thoughts on how much of the exact problem you're trying to solve do they need to have experience with versus, because technologies change, and especially now with all this open source, like all the research that's out there, all the tools. Can you talk a little bit about?
So just to clarify your question, do you mean like how much knowledge of the problem they're trying to solve? You mean the domain, like the area where the problem lives, or the knowledge of the foundations and the tools to actually solve the problem? Because, for example, it could be a problem in retail. Do you need to understand retail, right? Or is it one of the tools?
I work in law, so
okay.
They're not going to understand law.
Okay, got it.
It's more about knowing which tools.
Got it, okay.
Yeah. Just need to be able to be comfortable with, doing research and using other people's stuff. Yeah. Or what is that point where they actually need to be like specialized in something versus general?
Let's start from Rodrigo there.
Yeah, I'm not sure I fully got the question though. Like, so you're saying from the perspective of. Yeah, but you're saying that's from the perspective of like whoever is going to use your system, or like the person who's.
No, I'm hiring my first data scientist.
Okay. And you want to know whether your data scientist needs to like understand law.
Solve, like how focused is the problem that we're solving does he already need to have experience with versus working on solving various types of problems.
Yeah. So for example, like if I understand correctly, like you're in law, you're hiring your first like data scientist. Like, does that person need to understand like law, the problems that you are? Is that what you're?
No, the AI technology. So for example, we're doing text analysis. And we pretty sure like we were going to use like neural networks and this and that, and like so how much of the exact tools are what we think we're going to need to be experienced with versus generalist in. Right.
So I think they need to, well, it's a little bit of both, isn't it? Because like in the end, like you in AI in particular, you have different types of models that you can use, different techniques that you can use depending on the problem that you have. It's like even, so for example, like if you if you want, I don't know exactly what you're trying to solve in your space, but if you want something that like looks at the text and extracts some semantic meaning out of it, there are different techniques that you can use. Some of them are going to be more algorithmic because like they're old, and like as Sam said, like in AI, once like a problem is solved, like it's not AI anymore. So like some of those solutions are going to be more algorithmic. Some of those solutions might need like some more. Let me use the word like modern, like a machine learning technique. And so I think like the best professionals you probably can hire are ones that have at least like a good understanding of the environment and the different techniques that can be applied, and enough like, for lack of a better word, like enough capacity and will to go deep. Once like you narrow down which technique you want to use, go deep into that technique to implement the best possible system that you're going to need. So it's like a mix of breadth and depth, I think.
It sounds like fairly applied. It's not like you're trying to advance the research in certain areas. So if it's fairly applied, then you need a person that knows how to read papers. Microsoft specifically in the context of text summarization and text inference, not in legal context, but just generally, they publish quite a lot. And so, I would hire maybe a person that can read academic papers, but can write code too, because to a large extent, you would have to go through, TensorFlows or Amazon Web Services to process a lot of this data. And so a little bit of both, but it doesn't seem like you would need a person that can read academic papers but not produce them.
And also, I think having enough intuitions of how the systems work, right? So the danger I see is some of the candidates like, oh, I ran this on TensorFlow or MXNet, right? So they kind of say like they did this, but then they are not able to explain what exactly they did. Like, what is this? Like, so it can't be completely black box, because once they start finding like errors, or once they start seeing like things not working as they expected, right, they'd be lost. So I'd like have somebody who is able to explain what the algorithm is doing, even if they don't have to come up with new algorithms.
I think this is a challenge, because over the last maybe 5-10 years, there's so much rebranding of professionals around data science and machine learning that now it's like you have everyone from everything from like someone that Animo, you're saying that they just like putting buzzwords on things that they have touched at some point, right? To people that actually are understand the inner workings of it, and it depends on what you need. I think you have to. I like the idea that you need someone that can both understand the theory, read the papers, but also be savvy enough, because you have to glue so many pieces together. As good as TensorFlow is, or the tools that we have, it's still kind of like, I remember when I first joined, like just going online on the internet, it wasn't like it is today, right? It's like it required a lot of gluing things, right, to make it work. So I think you need to have people that are very versatile, and they can hack their way through it, because it's still very much I think a hacking environment.
So I would like to touch on a more fun aspect of AI, and that is, when will it help the work week decrease from 40 hours to 20 hours? I mean, right?
Yeah.
Before the Industrial Revolution,
yeah,
work week was about 60 hours, it dropped to 40. I would think that's not a matter of losing our jobs, but they should do their work for us, isn't it?
Yeah.
So what about 0 hours?
Yeah.
But that's what I'm looking for.
Well, but if that's the trend, like why not go like full throttle into it? Like if the trend is that, right? Like with automation, let's say Industrial Revolution, like 60 to 40, and then now you're saying it's like, well, like then with further automation, like 40 to 20, and then like what is next? Like the $1 million question is like not like the next step, but like the end. Where are we heading? It's like, are we heading to a like
income?
Basic income.
Yeah.
That's
Norway.
I mean, that's a good question, but I would love to do exactly what I love every day and everything else, not necessarily use a good part of my day just to bring income to pay my mortgage.
Well, but for example, did you have to hunt today to eat your meal?
Yeah.
Did you have to farm? Did you have to farm to eat? You did.
Did you have to plant your own crops?
Progress, but
But also I think earning a livelihood or even like kind of generating more wealth has been one way technology has progressed, and that's been a way the society has been motivated, right? Not the only way. And now if we take away no working, then what is the, I mean, there probably then we can think of other motivations, the artistic aspect or research or, I don't know. I mean, if we like replace saying like, oh, no one has to work because they don't have to earn a livelihood,
I mean,
it's an interesting question of what else would they be motivated by?
My intuition is that, so very concretely, right? In maybe 5 to 10 years, you're gonna get a couple hours a day for free because you're not gonna be driving your car anymore, right? That's very realistic, right? You're not gonna be working 40 hours a week anymore because you're not gonna be driving for a couple hours a day. And that's substantial, like that's substantial, right? That's time that is saved that you can go back home and play with your kids.
Well, the key question is what you're going to do with those 2 hours.
I'm not.
Browse more social media.
That's right. Okay. More training data. More training data.
But I'll challenge Samuel like right there in like those 2 hours because I live here in the city. I was working at Facebook, and then I would spend like 1 hour commute each way every day. So it's like make 2 hours. Like the first, I moved here to San Francisco like 3 years ago or so. Like the first time I did that, I'm like, okay, I need to find a way like out of this. Like I just can't. I can't waste 2 hours. And then you realize that like today, like with the technology we have today, there's already like a huge amount of things that you can do on those 2 hours that will make them like useful. So it's like you don't need to wait 2 years like to take those 2 hours back. Like I took my 2 hours like, I don't know, 3 years ago. All like I had to do is like choose things that you can do with like with your ears. Take like an audiobook, for example. Like I read like more than like 2 books a month, and during that time, and it's amazing. It's like I love reading. It's like you do that. Like take a radio or like information. It's like you can educate yourself like while you're driving, and you already take those 2 hours back. So you don't need to wait for that.
I agree to a large extent. My take on this is that you won't be working less. You'll just be doing other stuff. It'll be different work. But the other point too is that the other angle to this, which is not AI again, the problems get solved, they don't turn into AI anymore, is virtual reality, right? Why do you even have to have a car to commute to work when you can, if Facebook solves virtual reality, which I actually believe it may, because it's actually pretty advanced with Oculus Rift. Yeah. Plus there's a lot of money in this industry. If just Skype or hanging out, right, just really enabled you to not have to go to work every day. Working from home is the reality to a large extent, and that will only get better. And so we don't have to go look as far as 100 years to look how these things will transform your work-life balance. Some very early things that are happening right now, I think, will substantially. So.
One thing that you said that I think it's Samuel said that I think it's very true. It's like nobody went hunting today, I believe here, but I think it's true. That's like the nature of work is changing, and I bet if you were to go back 100 years and ask people, kind of look at these people what they're doing all their day, they say they're not working, right? For sure. Because they're sitting there and doing nothing, right? Or seemingly doing nothing. And the reality is that the nature of work is being changing for a while. Actually, I think I just heard on NPR that they're looking into productivity numbers in the U.S., right? Which seem to not be trending necessarily with the adoption of technology, right? And one of the possible reasons is that actually people are goofing more at work, goofing off, because now, they can be in their computer, but they also have like, WhatsApp or Facebook or something on the side. So they're like socializing and working at the same time, right? And if we were to go back, we wouldn't call that work, right? So that's changing. So maybe like in 30 years, we're all gonna be like, painting and doing things like that and be like, oh man, this sucks, and that might be the future. Yeah.
So if I can add like just one thing, which my general thought on this whole area, and sorry to pick on you, it's like I think the technology, and it's not like in the future or like I think technology today, it's like what it allows us to do is like to do more with less effort. And that happens on a daily basis. Like every new tool, every like new technology that comes up, every new app, every new algorithm, it allows you to it bridges a gap. Like it allows you to do something that you couldn't do before faster. Now it's up to you, and up to us as a society to decide what we want to do with that time. And you can continue to work like your 40 hours. And then you're going to do way more than you did before. Or you can say, like, I want to keep doing exactly the same amount of, I want to have exactly the same productivity I had before. But now you can have those kind of results with with half of the effort, or maybe even less, like 10 hours or so. But then the implications of that now is like it creates this discrepancy where like some individuals might actually think that, okay, so that's all I need, so I'm not going to work extra, and then I'll goof off, and then I'll spend more time on Facebook or Instagram during like work hours, and then you keep having that regular outcome that you had before. But then you're going to have like smarter individuals or like more ambitious individuals that will like, whoa, wait a minute, like I don't want to be like that guy. Actually, if I have this technology today, I'll do 10x the amount of work. And now that guy is going to eat your lunch. Because, well, not literally, but it's going, like that person is going to have so much more productivity, and you create this discrepancy where like some individuals might linger because of like that technology advancement and that idea that, well, now that I have more technology, I have more time that is free, and I don't need to do anything else. Where other individuals will prosper in our competitive society. So I think like that is kind of like where we are heading, and that happens on a daily. It happens today, right? Like you have information that is like out there in the wild. It's like that didn't exist. That didn't exist when I was born. Like you want to have, like, let's say you are born poor in like a Brazilian slum, and you wanted to have access to like information and education in general. It's pretty hard to get it. It was pretty hard to get it like 20, 30, 40 years ago. But today, everybody, like even the ones living in the slums, they have like smartphones with access to the internet, and the Wikipedia is there. You have that information. So the technology is there, and like it allows you to wake up in the morning and you can do something that was like literally impossible like 30, 40 years ago, which is learn everything that exists in the world. And that information can be extremely valuable for you to prosper in your life. It can take you out of that slum and like make you a rich man. And I'm not joking, like that is true. And still, like those people, like who have access to that technology, who have like the understanding of that situation, their social, like economical state, they decide to spend the whole day playing, I don't know, like whatever game is trending today on their phones, or like taking cool videos and doing like those stuff. I think like that is a very important question that in the end, like we have to ask ourselves with that trend of like technology enabling us to do more with in less time, is like what we want to do with that time. Is it like, do we really want to goof off? Because if you make that decision, somebody else is going to make the other one, and it's going to be like it's going to win you over.
I mean, one way to think about this is to ask yourself, instead of looking back, perhaps going back and asking someone to look forward. So if you ask someone during the agricultural times, when 90% of the population was doing agriculture, right? If they travel to the future of today's world, right, and they saw people that didn't have to do agriculture, right, and they were living, with life expectancy that were higher than before, or eating chocolate, for example, or or driving cars, they would say, why do you need all of that? Like, you're doing work for people that you don't need, for people that don't need it to be done. Because for that person, all they needed was to eat, right? To plant and to farm and to eat. That's what they needed before. And so today, for that person, what we have today is substantially unnecessary in that, for his perception, it wasn't needed. But the world evolved, and so today we get to live to 100 years old world, right? We get to eat chocolate. We get to have a lot of these things that are more advanced. But in the future, you have to solve problems like, for example, we're eventually going to run out of space, or we have to colonize Mars. Existential problems, right? Like we have to fossil fuels are eventually going to end. We have to come up with a solution for fossil fuels. Mosquitoes kill more people than anything else in the world. How do we solve mosquitoes? And so to a large extent, there are plenty of existential challenges that need to be solved, and humanity will just find a way. I am of the position that I don't think people are going to be working less. They're going to be working. They're going to still have the same drive to evolve mankind, and they will continue working.
They'll do even more.
They'll do even more. They will have more tools, perhaps.
Yeah.
In the back there? Yeah, you.
What about when machines are better than people solving those problems?
They already are. You mean today?
Many of them, yeah.
You're talking about when we have colonized Mars. What about when machines can do it better than us?
But that is already true. Like if we humans wanted to go to Mars, we would have to terraform Mars. So like I think the colonization, if it ever happens, is going to be machines will go there first, like prepare the whole environment. Like probably robots will live in Mars for many years before humans can do that.
That makes human work unnecessary.
I mean, at some point, humans and robots would be together, right? They would not be distinguishable anymore. So that would be the cyborg future.
So if I understand your question, is like machines will work in collaboration with humans. I think for the time that humans will exist, like machines will be there to like help us as they do today, like help us achieve more. So that is the thing with colonizing Mars. It's like they're gonna have a purpose, which is they're gonna go there and like prepare the terrain and prepare things, and that's gonna be there. Like people tend to think of like the evolution of machine learning and AI as something that machines will become humans and will have these emotions and will try to like kill us and stuff. No, that's how humans are. Machines are like completely different, and they will be completely different like as they become smarter and smarter. They already are. Like machines will not have like limbs, and they will not like some of them might, but like even those who might do that, they're not attached to that body the way that we are physically attached to our bodies. And it's like we have emotions that like come from like years of evolution from other like biological animals, and like machines, they're very different. Like they don't have that heritage of like instinctive or like animal like DNA in them. So it's like you can't think of like machines in that like competitive way, the way like most people think. I think that is very primitive of us.
From a very research perspective, I think that the missing part that doesn't exist yet, which may or may not be created, is desire. Is machines that can learn not with a goal in mind, without a goal. Like people joke that cars will be truly autonomous when you tell it for you to go to work and it takes you to the beach, right? That's when cars will actually be autonomous, right?
My kind of car.
Startup idea. And so this notion of desire, right? This notion of ambition, machines are today's the status quo of research is that you tell it a goal, you show it what you want, and it will perform better than you. So you show it, all the work of Mozart and Beethoven, and it says, this is good, I want more of this, and it will produce of that. But it's not yet able to create new genres or new music, or whether music is good or not, or something that gives you pleasure that isn't what has been conceived yet. So it's goal-based. You tell it what the goal is, right? It much goes along the lines of managing people, right? Like one of the worst things that can happen when you manage people is when you tell them to do something that they do exactly what you ask for, right? You want, much like parenting and managing, right? Humans are still able to, you give them a foundation and they surprise you. There's serendipity there, right? When you raise kids, you raise them, and they will outperform you. They will do better than you taught them to do, right? Because they had the drive. Much like managing too, with a team, you enable people, and you hope that it will come up with something better than you had in mind initially. That's what, in my intuition, you can tell a little bit more about the research, but this notion of desire isn't yet modeled well.
And I want to close, Anima, with your comments, because I think just part we went overboard on time, and it's a fascinating topic. So maybe if you want to do your closing words on this.
I was just going to add at the same time, humans will be augmented more with technology, right? We already are in a lot of ways in terms of our devices, but also in terms of pacemakers and other things that will help us function better. And there is engineering organs and stem cell research, gene editing. And so that's the other direction of us getting more robust and out of all the diseases and all that stops us from living longer. So that's the other direction I see us coming to convergence with machines.
I'm glad we closed on an optimistic note. So thank you so much. I mean, this was fascinating. Thank you.
Thank you. Thank you. And Vicente, I have one question. Since 3 of the speakers are from Brazil and Anima is from another region, my question is, where are you coming from? Is AR already impacting the place you came from? And if not, how long it will take? Rodrigo?
Do you mean like in Brazil?
Yes. Tell us your city, your state.
Oh, in my city, I'm from the south, the very south of Brazil, a small city called Rio Grande. I think there's it's a port city, so there's a lot of port-related things there, and automation is big in that sense. You want to build I don't know, a big ship or something. It's built mostly for these days. It's built mostly by automated machinery. So AI is old AIs is algorithms are powering most of those machines. But at the same time, in a more consumeristic way, everybody is using apps today or systems today that are highly personalized in their computers, in their phones, and that changes everybody's lives. So that definitely touches my city too. The fact that people are using, I don't know, Google or Facebook or Twitter or even Uber, and which are simple applications, but that rely heavily on AI machine learning, means that it's changing. It's touching my city too.
How many inhabitants they have there?
Oh, I don't know, 200,000, I guess. 200,
okay.
Now that he left a little, left fewer people.
Oh, 199,000.
Samuel.
I come from Campinas, São Paulo. It's a university city, about 1 million people. And so, from an academic perspective, certainly, massive impact in that the academia is really picking up. But to a large extent, the biggest impacts in the consumer-based space where, for example, one of the most meaningful ranking signals that Google Search has is something called Brain Rank, which is a machine learning component. And so, to a large extent, when you're searching, you're going through that work, right? You're going through that work. He mentioned voice recognition and voice synthesis. That happens too. And so, to a large extent, just today, internationally, right, in my city specifically, but just generally across the world, people are being impacted positively by these things.
Anima.
So I come from Mysore. It's a city next to Bangalore, which is the software capital in India. So there is a lot of movement in India in terms of having a lot of software engineers, and now artificial intelligence is a skill set that millions are developing, and we have a very dynamic startup environment, so a lot of startups in the e-commerce space, in the mobile space. The mobile penetration in India is now quite large, even in the smallest of villages. There are mobile phones, maybe not at smartphones, but definitely mobile phones, and that's changing how farmers and people in rural areas are able to get better prices for their produce, and also maybe get more updates about weather and so on. So there's a lot of social changes happening in India, I think, in a positive direction, and AI will play a big role in the coming years.
Vicente.
Yeah, I'm from Rio de Janeiro, and I think I think like go back to like all these apps that essentially are making us all kind of superhumans, and pretty much all of them rely on AI. So I was in Brazil a few years ago, I mean maybe like a couple years ago, and then I was like just kind of watching TV, like trying to get something done, and they have TVs everywhere because there's so many lines for everything. So I was in line waiting for it, and there was like this TV show showing like that, you know, a TV crew went to like a poor suburb of Rio, right? And they were there because like the bridge was falling apart. And they were showing like that, you know, some unknown citizen there actually could send a video of the bridge falling apart via WhatsApp to the WhatsApp account of the TV, and then basically they sort that, the people vote on it, and they send the crew, right? So I think these things are really kind of enabling and helping, in some ways bringing equality, right? Just as much as in some other ways not. So yeah, that was my experience with it.
Thank you, Vicente. Great moderation, great information. Thank you, guys. This was fascinating. How about a hand of applause to these guys? Thank you so much.